Hello, everyone. Thank you very much for joining us for this IFLA Science and Technology section webinar. This is part of our professional development webinar series. And today's session is on our Author Carpentry. It's a DOI hands-on workshop, and the title is Persistent Access for Research Outputs with Digital Object Identifiers. For those of you who might be unfamiliar, Author Carpentry is a researcher-to-researcher training and outreach program in open authoring and publishing, scholarly identity and reputation, and research impact. It's inspired by the modern scientific authoring lesson proposed by the Software Carpentry founder Greg Wilson. Author Carpentry was envisioned by founder Gail Clement to complement and extend the research pipeline covered in Software and Data Carpentry. Author Carpentry picks up the last mile of the research process: writing, reporting, review, dissemination, and licensing, impact measurement, and establishing author identity and reputation. Today's session is presented by Tom Morrell, Research Data Specialist at Caltech Library, and he's going to be giving us a 60-minute hands-on workshop. Tom, I'm going to stop sharing my screen and Excellent. I'll turn it over to you.
Perfect. Yeah, it's not letting me do my video, but I'll go ahead and share my desktop. Yeah, so it says I'm unable to start video because the host has stopped it. So I don't know what's up on the Zoom front, but does everyone see my screen?
I see your screen, and I'll see if I have control over the Zoom settings.
Excellent. It's always an adventure with Zoom and webinars. So welcome, everybody. Thank you so much for joining us. So today we're going to be doing a hands-on workshop around digital object identifiers. So all the curriculum that we're going to go over today is already online. I'm going to drop in a link into the chat. I'm going to be using the chat a lot for providing information, for copying and pasting stuff. And we want to make this as interactive as possible over Zoom. So if you have questions at any time, please put them in the chat. You can also use the question and answer feature if you prefer, but the chat's fine. And I'll answer them as they come up. After I do just a really brief intro, we'll do some hands-on activities. So please feel free to open up a web browser. Most of this will be with the web browser. We'll do a little bit of work on the terminal. So if you're able to, if you've done like the Software Carpentry introduction to shell lesson, and you're familiar with kind of opening up a terminal window using that, feel free to follow along with that. Otherwise, you'll see me do it live on the screen. There's also, there we are. Hello, everyone. So there's also some setup instructions on that workshop page that I dropped in the chat. So if you want to follow that later on, that's also available. Excellent. Okay, so now we're starting to look at what digital object identifiers are. So these are really kind of a key for working with scholarly information on the web. So what are they? Well, example, here's a DOI. This is the DOI that we're going to use for the rest of the examples in this workshop. It's an interesting paper that you can go and look up, and we will be looking it up momentarily. You are also free to grab a DOI of your own, a paper that you like, a paper of yours, and work with it. So basically, what's the most minimal thing? I'm going to copy this and put it into the chat so everyone has it. So what does a DOI do? Well, if we go to doi.org, we go in our browser. We do doi.org/ what that DOI is, and we get to an article. So this is the DOI for this specific open access article in BMC Medicine. So at its most minimal, a DOI is something that leads us to content. It represents an established international information standard, ISO 26324. there's a lot of kind of technical stuff, but it's at most basic. It's something that will go and take us to a piece of scholarly work that we're interested in. But it's much more, and that's what we're going to talk about today. Why do we care about something like a persistent identifier? Well, it's useful for making sure that we can have links on the web that don't break. So if you just drop in a URL, so like this article is like bmcmedicine.biomedcentral.com/articles. If we were to use that to reference this piece of work, that link would likely break in a number of years, right? As the website platform changes, as journals move between publishers, between systems, those links are going to break. And so what DOIs are designed to do is they're designed to be persistent. And that allows us as kind of information managers, or people that are managing these publications or repositories, to update links. So today, this DOI resolves to a specific publisher. If that publisher changes, we can then go in and change and have this link immediately redirect and forward to the new location of that content. And this is really critical. So I said, as Kara mentioned in the introduction, I run a data repository. We did a big migration of a whole set of climate data that were at Oak Ridge National Lab, and they were all identified with DOIs. They were cited in papers, and you could go to that and get to the data. What we were able to do, because they were all DOIs, as we migrated those data back to campus, one day those DOIs pointed to the Oak Ridge copy of the data. The next day they pointed to the Caltech copy of the data. So anyone that had bookmarked or saved one of those DOI links, all the DOI links that were in the published papers, they all continued working, even though the system had completely changed. So this is really nice. This is a persistent identifier. The other thing that's cool about this is that this is guaranteed to be unique. And we'll talk about the DOI structure in a little bit more detail later on. But this is the only, this is going to be the only existence of this. So we can reference this as this is what this work is. It's really helpful for kind of data analysis. What things are not? So DOIs do not tell us whether we're able to actually get access to a piece of content, right? So in this case, this led us to a landing page, and this is an open access article. So yes, we can get to this content. But this could have been a subscription article that we don't have access to. It could be linked to a data set that is only available if you have certain permissions. So the DOI is only going to ensure that you get to somewhere on the web, not that you're going to be able to actually get to the object itself. A DOI by itself is not a seal of quality. So, broadly, if something does have a DOI, it gives you some level of assurance that somebody that vaguely knows what they're doing is running the repository or the service. But there are no quality checks, right? You can, any organization can become a member of Crossref or Dataset or one of the other DOI registration agencies and mint DOIs. So it's an indication of quality, but it does not guarantee anything by any means. So you want to actually look at the content as opposed to just saying, oh yes, it has a DOI, it must be valid or useful. But the real value is not just the DOI itself, but the metadata that's associated. And this is what we're going to work with today. We're going to figure out how we can get more metadata and more information out of these DOIs. And the way we can do this is by knowing where this metadata lives. In this case, it lives with the specific DOI registration agencies. And in most cases, for kind of scholarly journal publications, large publishers, that will be Crossref. So we're going to start looking with the Crossref API. So what an API is, an application programming interface, is a way to get data out of systems. So this is kind of the landing page for humans. You can think of an API as an interface for machines, but that doesn't mean it's like scary or just like for programmers or stuff. It's really it's not that scary. It works just like kind of a normal web page. So what we're going to do, we're going to go in our browser, and I'm going to go to where this API is. So in this case, it's api.crossref/works. So basically, we have our API. That's the URL for the site, and then we're going to look at portions of the API. So we're going to look at specifically the works portion of the API, which gives us the metadata about a specific DOI. And then I'm going to just paste in our DOI. And for folks that are following along, you can follow along as I type, or you can look at the specific commands that are labeled in this section of the workshop curriculum. Okay, so when I go here, I'm using Firefox as my browser because it will automatically format the JSON, the underlying data that we're looking at here, to be prettier. If you're using Chrome, there is a plugin that you can do that will do a similar thing, and that's listed in the workshop materials. It's all the same data, it's how pretty it looks. So what we're looking at here is JSON. So JSON is a specific data format that works really nicely for this type of metadata. It's organized as kind of keys and values. So this JSON file has a label called status, and that tells us that this is okay. This is a complete registered DOI. It gives us that that this is a work. That's the object that it has. It also gives us what version of the API. So APIs can change over time. And then it gives the actual information about this DOI. And this is really rich. You can scroll through this and see lots of information that is useful. So when it was actually last indexed, who the publisher is. This is a Springer article. What license is associated with it. So you can see all the text and data mining terms for this specific article. See that it's what the article is, what type of thing it is, the DOI itself, when it was created, our title, our authors, our date, and then all the references. And these, you can see that the kind of quality varies. So some of them have the DOI for each of the references, some of them don't. This is all dependent on what the publisher makes available. But as a result, you can see there's lots of really useful data here that you might want to use if you were, wanting to find information about specific publications. So this is working with this in the web browser is really nice if we want to just take a look and peek, take a look at what's available for this DOI. If you want to actually do some data processing in your local machine, you might want to download this. One option for doing this is using something called curl. So we're going to open up a terminal window on our computer. You can follow along with this if you'd like. And we're going to look at an example of using curl. I'm going to go ahead and move to my desktop. Okay. I'm going to make a new directory so when it's clean. Okay, so now I've now made my IFLA directory. So what I'm going to want to do is I'm going to grab some of I want to take what Crosstalk makes available in the API and download that. We're going to use curl. Curl is a great tool on the command line for basically taking content, downloading it to our local machine. I'm going to want to put this into a specific file that I'm going to have that I'm going to be able to then save and use later. We're going to call this shen.json. Again, you can call this whatever you want. You can change the name. It's all up to you. And then I'm going to put what URL I'm going to get the content from. It's https api.crossref. Works. That's our API. And I'm going to just paste our DOI in here. Let me go ahead and do this again, just to make sure that I get the DOI. So this is the same URL that I had before, just I'm putting it in the command line with curl. It's going to say I'm going to download some stuff, and let's take a look at this. And you can see that this is the ugly version of the JSON file. So it's not the prettiest, but you can see it's the exact same information we have. We've got the authors here, so on and so forth. There are lots of ways of making this prettier. So if you go to the curriculum, there's an example where you can use JQ, which is a little command line application that formats this and allows you to pull out different elements. You can drop this into programming languages like R or Python that allow you to pull out the parts that you're interested in, do analysis. There's lots of stuff you can do with this once it's downloaded and available. But we only have an hour, so I'm not going to get into all of those options. What we're going to do is get some more specific components, specifically the citation. So let's say I don't want all this metadata. I really just want the citation that I can use. And I'd like it in APA style. Fortunately, all the metadata exists, and this is one of the things that both our DOI providers, Crosstalk and Dataset, are great at, is formatting citations for us. So we don't have to do anything with citation formatting. So the way we can do this is we can use curl again. And in this case, I don't want all the files. I don't want to say specifically, no, don't give me all the metadata. Give me just the citation formatted as something that I can read with APA style. And the way that I do that is I use a secondary option called headers. And it's just a way for curl to say to the API, this is what I would like you to give me back. So I use the -LH options. So L is saying specifically to follow links forwards. This is useful when I'm doing DOIs where there's a forwarding process involved. And H is to give it a header. And I think of the header here is really kind of a magic key. So there's some structure to it, but basically this is something you'd want to look up or look in the documentation to see how it's specifically implemented. So this says I would like to accept something that's text. Next-bibliography. And a semicolon for more specific options is that I want it to be specifically ACA style. Alrighty, so that's the kind of key that says this is what I would like back. And this one we can actually, we don't even need to know the API endpoint. We can just give it a DOI. And the DOI that we're interested in. This works. Excellent. So now it printed back what our formatted citation is in APA format, sorry. So that's pretty cool. So I just printed that to the screen. That might not be what you want. Let's say if we want to actually put this into a text file that we can do stuff with. I can use the up arrows to go back in my history and add a -O option. Show me that it's downloading it. And now I can take a look at that file and it gives me that same information. Alrighty. So you can imagine that if you had lots of DOIs that you wanted citations for, this would be really easy. Just run this command a number of times and get out your citations for your stuff. That's very cool. Another example that would be really useful is, let's say we've got a list of DOIs from, let's say, like a faculty member, and they want to upload all these to ORCID. So the easiest way to do this is to have a Bibtex output. So I'd have a Bibtex file that you can then merge around and do stuff with. You can actually use this exact same structure to get Bibtex. So we do curl LH again. And instead of using this header, we're going to use a different one. So I say application /next Bibtex. That's saying, please give me a Bibtex file. And we'll use this same DOI, same URL for the DOI. And now we're going to put our output in a .bibtex.bib file. Oh, I haven't put sending my links to host and panelists. Oh, I'm sorry, folks. Please do complain if you're not getting the links that I put in chat. I'm going to go ahead and redo that link. So that is our DOI. And this is the section of the workshop that I'm using. Do complain if you don't get links, folks. Okay. So great. Let's go ahead and take a look at what we got back as our Bibtex file. This is now our Bibtex file. Excellent. And so you can imagine that we can do multiple of these, right? So let's say we wanted to do 3 of these for 3 different journals. So I've got a couple of DOIs that we'll use. So I can go through and just swap out what files I'm going to use, what DOIs I'm going to use. And so now we've got our combined file. And as a challenge question, if you want to figure out how you could do this all in one script, this is actually really easy to automate. If you've got a list of DOIs, you can actually automate this to generate a full pubs list in one single command. So I hope this illustrates kind of the power and potential of all the metadata that is registered alongside DOIs. All righty. So now I have a little bit of time to go into some more detail about how digital object identifiers are organized. So the International DOI system is kind of the overall architecture, which is managed by the International DOI Federation. They're a nonprofit that does the governance of all the DOIs. And these are not just kind of scholarly DOIs. There's lots of different DOIs that are used for different use cases. So there's some that are like indicating specific versions of movies. So they're not necessarily all kind of scholarly stuff. There are different registration agencies that provide services to members. So they're responsible for kind of everything that is kind of custom. So the DOI itself will always resolve with doi.org. They provide the resolver service that will resolve the DOIs. But the registration agencies provide the additional services. So like the metadata that we looked at, that is specific to Crosstalk. So different, the DOIs will all work the same way, but the underlying services like the metadata may be different between different registration agencies. So the DOIs itself are organized by in kind of different components. They will have this directory indicators, this 10 point that indicates this is a DOI, and they have this prefix, this number here, so in this case 7935, that is assigned by the DOI registration agencies. And these are organized by by kind of the group that is minting the DOIs. So for a publisher will have a specific DOI prefix, a data center or a data repository will have a different prefix. And this is really useful because then each organization with a prefix is responsible for everything that comes after. So this is the suffix. And so these are assigned by the specific organizations. So, F1000 Research, California Digital Library, Caltech Data, and they're responsible for what the content is in the structure here. So one of the big things that is a benefit of DOIs is that the prefixes don't communicate any information, right? They're just this number. So if it was something like 10-point nature, the reason that that's not a good idea to have as a persistent identifier is when nature and science merge and suddenly they want to label all their stuff as nature science, they would be very tempted to break all of their links. So if instead it's 10.7935, nobody knows what 7935 is, then that'll stay permanent for a longer period of time. Similarly, that's also recommended for how the suffix should be structured. So this should also not ideally contain any identifiable information that people want to change. You will see all sorts of variants if you look at publishers, you look at data services. They really are very tempted to put branding and other stuff in here, which isn't the best. But as I mentioned, everything in the suffix is the responsibility of the individual groups that are minting the DOIs. So if you look through some stuff that publishers do, they'll do some really kind of wacky stuff with the ends of DOIs. But that's kind of the structure of the DOI itself. One question we get a lot is, okay, how do I know, these prefixes, if I just look at the numbers, they don't tell me anything. How will I know what these things are? Well, fortunately, there is a very easy way of figuring this out. If we go to doi.org again, and instead of dropping in the DOI, we just give it a prefix. So 10.14291. This is just the prefix, not the DOI. This is not the prettiest information. It actually looks worse if you look at it at the API level, but it has in here information that this is a data site DOI. So this is useful because it tells us where we can go look for more information. Similarly, if we look up 10.1021, we can look down here and it says, this is a Crosstalk DOI. So we can go find there more information there. Some of the Crosstalk ones actually have additional information that'll suggest who like the publishers. In this case, you can say, it's ACS, but that's not guaranteed. What is guaranteed is you can then take that information and say, I can go to the registration agent, in this case Crossref, and find out more details. So if we go to api.crosstalk.org/prefixes, it will now give us more specifically, okay, who is the specific member, what's their name, in this case ACS, and then return back that prefix. Similarly, you can do the same thing. We just switch out Crossref for data site and look at 14291, which we know is a data site prefix. You'll see that this is Caltech Library is the owner. Caltech is the larger kind of consortium provider for that. So you'll notice that the specific, this API path is basically the same, but the specific structure of the data is different between Crossref and DataSite. Because the different providers can have different metadata structures. It's up to the specific provider what makes sense for them. But you can get really useful information about who owns what and how they manage stuff. Alrighty, so I want to take 1 second to see if we have any questions about anything that I've done up to this point. No questions. It's late in the day. It's all right. Okay, so the next section of this workshop is actually getting a DOI for ourselves. So this is exciting. So there are lots of different places you can get DOIs. So, Open Science and FAIR Principles really is encouraging scholars to put more of their content online in an open format. And fortunately, there's a whole bunch of different types of repositories that might be appropriate for your scholarly works. There are kind of domain-specific repositories that's focused specifically on a given type of data or stuff from a certain type of field. So if you look at in the workshop materials, there's a really good listing of all sorts of repositories at PLOS, and there's basically every sort of repository you could possibly want at Re3 Data. There are also institutional repositories. These are often run through the library to preserve scholarly materials or data collected at institutions. So for example, at Caltech, we have Caltech Data, which mints DOIs for Dataset software. We have our thesis repository where we mint DOIs for all of our theses, and we also mint DOIs for all of our tech report series. So your institution may do a similar thing, or if they don't do it already, you may ask and they might want to set that up. It's a really useful service for identifying and allowing people to access scholarly content. And there are a whole bunch of generalist repositories out there that will also accept different types of scholarly content. These can things that are associated with like a publisher, like Figshare, Mendeley Data. There are general repositories that are open to everybody, like Harvard Dataverse, Dryad, or Zenodo. And today we're going to be using Zenodo because it's a really nice, free open source repository. It's associated with CERN, which provides some nice institutional backing and permanence. So what I'd like to do today is I'd like to go ahead and generate a DOI for a very small set of slides here. So I'd like to make these slides available, provide them with a persistent DOI. Why would I want to do this? Well, DOIs are useful in terms of being able to reference content. So let's say somebody else wanted to use these slides. I'd like for them to give me credit that I created the slides. So if I put it in some place that gives me a DOI, I can have the person automatically you say, okay, please use the DOI. That gives them immediately a way to be able to cite stuff, put into reference managers. And it also allows me, if that citation is referenced in the metadata of that object, it allows me to figure out that somebody else has used my work. So it becomes really, it allows you to put works that might have previously gotten lost, stuff like conference presentations, data sets that aren't really published. It allows us to get more content into the scholarly ecosystem. And at the morning session, we had some really great comments, people that were like, this allows scholars to put up results that might be negative, might be just a replication of content that's already been published. So it allows us to put much more stuff online in a way that allows people to get credit for it. Okay, so we're going to walk through getting a DOI with Zenodo. So I'm going to go ahead and open up a new window. So Zenodo is open to everybody. You can log in. If you've got an ORCID account, everyone should have an ORCID account. ORCID is a wonderful persistent identifier for individuals. We've got another whole workshop on that. And it allows you to do things like logging into Zenodo, so you don't have to have a second set of logins. You can also log in with your GitHub account. I'm already logged in. I'm going to go to my upload screen. I'm going to request a new upload. All right, I'm going to go ahead and so now what we're doing here, you remember looking at all the metadata that we saw before for the articles. We are now in the process of creating that metadata. It doesn't come from the air, somebody creates it. So we're going to go and say what type of object this is. So it's a presentation. And here I can click this button and I can reserve a specific DOI for my object. And this is very nice. I'm reserving this before it's the content is actually uploaded. So this is cool because I can then now put it onto my title slide, and then people can, when I upload the things, people actually see what the DOI is for it. Another line in there. Let's make this a little bit bigger. That looks good. So if you'll actually click on this link, it doesn't actually go anywhere because I haven't actually published the item in Zenodo. I haven't uploaded any files. It's just pre-reserved this. So I can do stuff like this. I can actually put it on my slides. I'm going to go ahead and download this as a PDF. Don't know why Firefox does this. I'm going to put this on my desktop. Actually, I'm going to put this into my IFLA folder before. Excellent. Okay, so now I've got that. I'm going to now go back to Zenodo. And we're going to see if I can actually upload this. So I love Zenodo. It's wonderful. We use it for all of our repository. Caltech is based on the Zenodo codebase. But the one area that it sometimes is finicky on is this uploader. And it's a work in progress to get a new uploader in place. Let's see if it works today. It did not behave correctly in the morning session. Let me see if I can get it to, yeah, it's not happy. Okay. Go ahead and refresh this page. We'll see if it'll behave better now. It works now. So sometimes you do have to refresh the page. I don't know why, but this is something that we're working on as a community. Okay, so we've got my file uploaded. I'm going to go ahead and save this. Got my DOI. Okay, it has. So we need to provide the publication date. We need to provide a title. I'm going to go ahead and just copy and paste this, so that matches that. So this is all the information that we need for basically a citation. Needs an author, which is going to be me. An affiliation. And then we can provide an ORCID identifier. And it's nice to provide an ORCID identifier because then this will get automatically populated into your ORCID record. A brief description. Excellent. So we've now got some metadata that we can use. If you have a version, you can put that in there. I have a version of this. Put a keyword. You have an option for how your content is going to be accessed. So whether it's open access or it has some sort of restrictions or embargo. As I mentioned, this is not associated with the DOI. So DOI can lead up in content that you can't access. It's also good to assign a license. So for how people can reuse your content. In this case, the default is a CC Commons, Creative Commons attribution license, and I will leave that there. There are, as you can do funding, if you have European Commission funding, which I don't. And another important section is related identifiers. So if something is a citation, if we cite some stuff, it's good to put this in here as relations. That allows for automatic linking between citations and content. There's a whole bunch of other metadata fields you can fill out if they're appropriate for your work. In this case, I'm going to go ahead and save this. And I think we're good. I'm going to go ahead and publish this. And we now have a record with a DOI. And that DOI leads us to the expected landing page. So that's how easy it is to get a DOI for your own scholarly content. It just takes a couple minutes. You work with Zenodo, you provide a little bit of metadata, and you get now a nice citable unit that you can utilize down the road. So you can get credit for your works, even if they're not published in a traditional publisher. So these DOIs are registered with Dataset. So let's go ahead and look at the Dataset API. So what I can do, I can say works DOI. And this now gives us the information that we just created. So I just made this title up here, Slides for Author Carpentry, Persistent Access for Research Output with Digital Object Identifiers. It gives us our description. It says where it comes from. It says it's a presentation, which is what I selected for what this content was. It gives us our license, which I selected CC BY. And it says where it's coming from. So it's from Zenodo is the data center. CERN is the member that is responsible for that data center. So just like that, we have now a registered DOI with content. We can also do content negotiation. So let's go ahead and switch back to our terminal window. So let's say we want our APA style citation. There we go. So now we have a formatted citation for my work that I just created. So that's the whole life cycle of a DOI. We can generate DOIs as researchers, as members of the research community, and then we can utilize them for tracking stuff around that content. Alrighty, so that's the whole life cycle that I have. We have a little bit of time left for questions. So feel free to drop questions into the chat or use the question and answer feature if this brought up any sort of questions at all. Well, it looks like that is all we have then.
Thank you very much, Tom. Um, if we're done, I will share my screen again because I have a little bit more of IFLA housekeeping information to share with
Excellent.
all of you.
Go for it.
So, if you all are interested in seeing more of these IFLA professional development webinars sponsored by the Science and Technology Library section, please follow us on social media. You will find that we have recordings available on our STL YouTube channel, and here is the URL for that. And thank you very much for attending today's session. I see that there is one more. Nope, it's Tom's DOI that popped up in the chat. So I'll go ahead and stop the recording.